And now I'm pleased to introduce Chris Wilkowske. He has worked as a hydrologist for USGS since 1996 when he was a master's student at University of Utah. When he moved to Moab in 2009, he became supervisor for the USGS Moab field office. He's responsible, or the USGS office also is responsible for stream gauges in southeastern Utah, as well as measuring groundwater levels, running water quality stations, and operating several weather stations, and a lot more too. I'll let him tell you more about it. As seems fitting, Chris is also an avid boater, and please join me in giving him a warm welcome.
Thanks, Jesse. Thanks to the library for having me. It's good to get out and share some of the USGS information with folks. And thanks to Cora Phillips. She's with the Grand County Sheriff's Office. It's kind of her idea to, I started talking to her about some USGS data and how to get it. And she said, well, it'd be maybe a good idea to get this out to the public so people know about your data. So in thinking about it, you know, there's a lot of people who use our data, you know, water rights issues, boating, recreation, but the main thing I think that Cora brought up was, you know, the picture you see here. This is a picture of Pat Creek last year, and the flash flooding issues that happened in Moab last year. So I'm going to kind of talk about how a couple ways to get our data, and then I'm going to go into a little bit of how a stream gauge works, as we get that question a lot. And then at the end, I'll kind of talk about what happened last summer and maybe what will happen this spring. This is sort of our boilerplate, you know, thing, the rah USGS, just to explain who we are, kind of what we do. We're the Science Bureau of the Department of Interior, kind of an independent fact-finding agency. We don't have to deal with any regulatory stuff or any really policy functions. So other federal agencies kind of turn to us usually for science, basically. We also work with a lot of other state, local governmental agencies through cooperative partnerships. So over 2,000 different state, local, tribal governments. That's what we try to strive for, just the facts. So, you know, why is the USGS do it? Why are they the guys running the stream gauges? I was thinking when Jesse was asking me for some of my background, like when I first started, I had no idea. I started working, I think I was working in the USGS for like a year. And then I asked someone who all these other guys were on the other side of the building. And I said, they're the ones who run the stream gauges. I was like, what? Yeah, the ones that tell you the CFS, the river. It's like, oh, wow. I didn't even know that. But we've been doing it for a long time. John Wesley Powell, he was responsible for installing the first stream gauge on the Rio Grande at Embudo, New Mexico. He was the second director of the USGS. The USGS was really kind of his brainchild. So he got the stream gauge at Rio Grande going. Soon after, they kind of spread throughout the West. Green River started in 1894. Our gauge at Green River. Our network has kind of, it's grown, and now it's over 11,800 gauges. And like I said, we have 1,500 different federal, state, local, tribal agencies. So it helps. The way I think it's grown is the USGS has been able to use some of the power and the money of the federal government to leverage some of the costs that go into running a stream gauge. So a local government like Moab City or Grand County can afford to buy into a gauge where they have interest. So it's a good cooperative working agreement. I think the only downside is we have an ad hoc, what I gotta call an ad hoc network. It means it has not been really designed for one big purpose, like flood monitoring in Moab or certain issues. Gauges are put in place because somebody wants it there specifically. It's like sometimes the big picture can be a little lost. There can be gaps in some of the data. That's why you don't see a gauge on every single creek. Those are some of the cooperators that are local cooperators. So some of the gauges that I'm going to be talking about tonight are funded by the USGS and these folks. Bureau of Land Management helps pay for the gauge on Upper Mill Creek by the diversion to Kins Lake. Bureau of Reclamation pays for the gauge at Colorado River at Cisco. USGS also puts in a big chunk of money for that. State Water Rights pays for a lot of gauges on Mill Creek and Pack Creek through cooperative agreements with Grant County and Moab City. And the Utah Division of Forestry, Fire, and State Lands, they pay for the potash and the Green River at Mineral Bottom gauges. Just want to give them credit. There's a lot of people, a lot of your hard-earned taxpayer money is going in to fund a lot of this. So just sort of jumping in here, people have looked for USGS data before. There's kind of what I broke it down in an old way to get data and then sort of a new way. So the old way, the old reliable way, is a table that looks like this, kind of a static table. It actually is very handy. There's changes to our website. This is not going away because it works very well. It's very simple. If you have low bandwidth, you can get to it, everything else. This is the new version, the new fancy, what the USGS calls a National Water Dashboard. It's a map-based interface, so you can scroll around to your particular area. There's a lot of things you can overlay on it, like weather and radar coverage. Really handy to use if you see a storm coming over Moab and you want to know what's happening at the gauge and is a storm going over a certain drainage. And I'll kind of get into this as we go through. I sort of set up this talk to show like a live demo of how to get to our information, but I also put in static slides in there. So if people, I don't know if the library can post the presentation online or if I can email it to you or whatever, if you want more information there. I mean, here's the link here, but the easiest way is if you Google USGS Utah stream flow, you're going to get that table that I showed. That's the easiest way to find the data. That's that. So, click on the site. All of our sites are numbered. That's a kind of internal thing, but they're all pretty much descriptively labeled so you can figure out where they're at. Click on that and you get to the site page is what we're referring to it as. If you're used to looking at USGS data, this is a new look. A lot of people don't like the new look. Like if you're one of those, you're not alone. People in the USGS aren't super fans of some of the changes, but they tell me they had to update the web page because the old web page was outdated web technology, I guess. I don't know. Anyway, you could still get there for a little bit longer. Legacy real-time page, but they keep threatening to take it away. So I'm going to kind of show you how to get used to using this page. This is one of the big things that bugs people. The first thing that pops up when you click on the gauge is gauge height. And I'm going to get into gauge height a little bit later and explain what that is. But most people in this room, I think of rivers in terms of CFS, cubic feet per second. The reasoning was they said, well, there's a lot of people back east that they look at this river stage, like on the Mississippi River, you want to know flood stage, or like in a tidal area, you want to know what your flood inundation stage is. Anyway, it's been a point of contention, but here's the trick. Legacy real time. Let's see here. You just scroll down and then you can choose discharge right there. You click on that and change it. That's the trick. But it's when the page pops up, you don't even see that. So you got to scroll down. So up there at the top are those tabs where it says data inventory. That is kind of like a key to digging into a lot of other data that goes with the gauge. Each gauge has a record of past peaks, the peaks for the year. It has links to past old historic data in terms of what we call daily data, daily averages, or instantaneous, like every 15-minute data. So a lot of that you can get right there. So this is, if you click on that data inventory, you kind of get this listing all of the available data. This is for Colorado River at Potash. This gauge hasn't been around that long, so it doesn't have a huge period of record. But if you were to click on like the Green River at Green River, Utah gauge, you'd have data going back to 1894. The one that I was going to just show that I use a lot, and I find it useful in referencing when people are asking me about floods and things like that, to look at the past, what's happened in the past. So you can see that on the peak stream flow there. So that's it in graphical form. You'd also see it as a table, so you can get the individual numbers of the peaks for every year. So this is for Colorado River at Potash. We started the gauge in 2014. The highest peak that's been there at the Potash gauge is, I think it's 36 or 37,000 CFS in 2019. So the other way is the National Water Dashboard. And it might be, I'm thinking it's probably easiest if I can get this to work. Instead of the static slides there, I figured the live demo would maybe be a little more interesting. Okay, so those are all of the stream gauges in the US. And if you this is Google the USGS National Water Dashboard, this is what you'll get. So I forgot my mouse. If you have a normal mouse, you can just draw a box and zoom in on it like any other, map interface, really. The colors are, they're indicative of what the stream is compared to past values. And to see that, if you click on this legend box, so the blues, forgive me if I screw up the colors here, I'm colorblind, but the blues, so that station is much above normal for this day of the year. That's the Uncompahgre River at Delta, Colorado. This is the San Rafael River near Green River, 368 CFS right now. Right now, our bigger rivers they're more in the yellow. They're in normal stage for now. So if you just hover over the, oh, thank you. If you hover over the site, it'll give you that pop-up window that'll show you what the current conditions are. It also tells you down there on the bottom, normal for this day of year, decreasing 400 CFS per hour. If we had this one, South Creek near Monticello, all-time high for this day of year. And it's really interesting if you see one that, it's in a flash flood, it'll say like increasing, 1,000 CFS per hour. But if you click on that, it'll bring up another page. And on this one, the first graph to pop up is discharge. It's a little bit more limited, than the official site page. So if you really want to dive down into the data, you can just hit that and it'll take you to the main site page. But these are all the things that we monitor at the Colorado River near Cisco. We have a lot of water quality parameters that we monitor there. This is the legend that kind of shows you all those categories. So it's kind of color coded to show you where the action is. The darker blues and blacks are kind of where the action is. If you click on that layers button, right now we're looking at the stream flow and the status. That's the status is the color of those. You can also look at weather conditions and radar. And right now it's in static mode, but you can turn it to a 1 hour loop. So you can actually see the motion of the radar signal. We got nice sunny weather here, so we're not seeing anything in Moab. But, for instance, you can see the storm clouds moving over. And I used this a lot last summer when I was watching the storms roll over Moab Valley and trying to pay attention to what was going on at the Gages. Let's see. Oh, you can change the base map if you want a satellite image. If you're familiar with map interfaces, they all kind of work similarly like that. You can look at snow coverage from SNOTEL stations. And to be honest, I haven't played around with a lot of these things yet. This is fairly new to me as well. But for USGS stations, right now we're showing stream flow. We can also show surface water levels. And this button will give us National Weather Service flood status. So if we turn that on and then turn off stream flow. So I'll plug in the mouse. So I can drive one hand. If anybody has any questions, just feel free to shout them out. I'll find my USB.
How do you measure the flow?
I will be getting to that actually.
I have a question.
Yes.
Given the general snowpack and its increasing pack as we're speaking, are we looking at a historical high, 1,000 CFS, or am I just going to have to come back next year?
The short answer is no.
Next year is.
We are at historical high levels of snow, for the LaSalles. 100,000 CFS. I don't think we're going to make that. It depends on where you're asking, though, I guess. But the answer is probably not. Okay, now I think we should be. Okay, now we have gauge height, which is the Weather Service flood stage, and let's just see if we can look at the legend. So that is in major flood stage. Oh yeah, the Mississippi, I believe, in Minnesota is in major flood stage. So yeah, that says, pop up and say in major. That's an official designation by the Weather Service. The only downside about that for our area is there's only a handful of stations where they've actually designated an official flood stage. And those are the Colorado River at Cisco, the Dolores River near Cisco, and Green River at Green River. They don't, and you can see like some of the stations are, well, you won't see any flood status, even if they are technically what we would locally consider flooding. So I don't know, it's maybe somewhat useful. It's definitely more useful in more populated areas. Oh, let's see. I put these reminders on there to remind myself. In the tools area, you can choose first you can choose a language. If you're a Spanish speaker, you can change it to Spanish, which is kind of cool. And you can change your area of interest. If you just want to look at Utah, or you can click on a state, you can drag a box. Like, there's so many stations there, I can't. Oh, I have to hit control click. That's saying right there. There. So then it'll just zoom in on that for you. Okay, so these I put in, like I was saying before, I put in these sort of static slides just so they'd have some reference, and in case I forgot something. I think I showed you that. Site page and data will take you to those same data inventory. And then the other thing that I wanted to talk about is water alert. And pretty much every site page has a link to water alert on it. And water alert is the USGS system that will send you a text or an email. You set up a certain threshold and it will send you a text or an email. So if you want to know when Colorado River is at 100,000 CFS, you can get pinged and know that. So this is, back to our site page, there's a button right down there, subscribe to alerts. There's also, I took the screenshot before they made an update. Now there's great big buttons at the bottom of the screen. It's really hard to miss. Yeah, and so you can sign up through the site page or the National Water Dashboard or there's the US, if you just Google USGS Water Alert, it'll take you there. And then I was going to show you how to set one up with using Pat Creek as an example.
That data is updated every 15 minutes.
Yes. Okay, so there's our Pat Creek near Pat Creek Road Bridge. You can just click on Water Alert. You do have to make an account to get access to it. It's just like anything else, put in your email and verify that that's your email and you're in. Just to make this easier, I'm going to cheat a little bit. So I have this one set up. I have it set up to tell me if discharge is greater than 100 cubic feet per second, and it'll send it to me hourly. Let's just say, I'll just get rid of that and I'll start from the beginning. So you can pick whatever thing you want. We have a rain gauge there too. So if you want to know if it rains over an inch, you can be aware of that too. But I wouldn't recommend that because some of our biggest floods, we recorded 0 rain at this gauge. Daniel Lay's here. He's got a precipitation gauge network that's above the gauge that is much more useful. Yes.
Webcam that's on that out there? When we were out in the day.
No, there's no camera there at the gauge. There's a solar panel and a antenna, a satellite antenna.
Right next to it.
On the bridge, there's a thing that's pointing down into the culvert. That's our stage sensor. That's what measures how high the river or the creek is flowing. And it uses radar. It bounces a radar signal off the water to determine the distance. Okay, so I want to know. This is for a lot of gauges. This button here is handy. What values have we seen in the past? It's not that handy for this gauge because it's too new. So we don't really have a record of past peaks yet that are in the database, unfortunately. You can do, if you want to know if your issue is a water rights issue, you might want to know when flow drops below a certain value, or if you want to know when it's higher, if we're interested in flood warning. You can use greater than, less than. You can also have it do it in between. If you say you want to do a range, you can do greater than and less than. I'm just going to have it tell me, like I set it up before, 100 CFS. 100 CFS on Pat Creek is not that much, but that's what I set it for me. I mean, I would, if I was just for general flood warning, I guess I would set it more like 300. 300 still isn't a flood level, but it's maybe you should start paying attention kind of level.
What percentage of the regular flow is that?
Well, Pat Creek is normally like the base flow is like 1 CFS. So, but the peak flows, and we'll talk about this a little bit later, some of the peak flows get up close to 2000 CFS. So, and then you can choose, do you want an email or do you want a text message? And you can choose, do you want it once per day or do you want it once per hour? If you know you're really, if you live on Pat Creek, then you probably want an hourly notice. And it'll keep notifying you if it keeps going up. It'll keep notifying you every hour until it drops back below 300 CFS. So then you just hit create alert. And I probably will get a text message here in a minute saying something about it. I changed it. It's pretty simple. This is for this location. You can click on here. I have one for every gauge. It's just my job to monitor what's going on with these things. This is super helpful. This is more helpful than me giving this talk, I think. But it's like all the questions you kind of want. It's got a YouTube video that's slowly loading, I think, here, which will step you right through everything on how to set these up. That's usually what's right here. It's not, oh, there it goes. Maybe. Yeah, everything you ever want to know about water alert and a little more. Okay. This is the email. This is what it looks like when you get an email alert. You get a little thing and you get a link so you can view the graph. Some people are really interested in Chinle Creek, near Bluff, Utah. And then I put our disclaimer. Comes off the Water Alert website. It says, USGS strives to prevent serious interruptions. There are times when equipment malfunctions and fails to provide data for Water Alert to use to send out alert notifications. Users are cautioned to consider the limitations of the service before using it for decisions concerning personal or public safety. Basically, it's, I was starting out talking about our gauge network, it was not designed as a flood warning network. This is kind of a add-on type thing, a thing that we hope is helpful, but it's not a robust system like the county's emergency alert system. So we hope it works. It hope, and the other part of the thing is our gauges do it during floods. They can get damaged. I mean, they can get wiped out by floods too. But all the other things can affect it, like most of our gauges are satellite. They transmit the data by satellite. If there's a satellite issue, if there's a computer issue back in the main server, all those things can go into that. Okay, shifting gears here now. This is basically a very simple schematic of what a stream gauge does. All it does is measure the height of water in a river. This setup here is showing, this is an old-fashioned stream gauge house, and this is what we call a bubbler system. And it's measuring gauge height. So in this example, water pressure is measured, which is converted to stage in feet by the instrumentation. So this is measuring, I don't know if you can see that on there. I can't see it. Sorry. Basically, it is measuring the water pressure above that sensor. The water pressure is easily converted to feet. So you can, and our sensors are very accurate. They'll measure the feet to the 100th of a foot. So and then we convert it to what we call stage or gauge height. And the stage is just simply, it's an arbitrary number. We usually get asked the question, does the gauge height or the stage, does that mean that's how deep the river is? And it's kind of what it is, but it's not exactly. We have this level down here, what we call the gauge datum. So it's arbitrarily set when we set up a gauge. We like for in this example, we say, okay, we're going to call that level 1 foot. And then the bottom of the channel is approximately, we usually set it below the bottom of the channel. That way we don't wind up with negative gauge heights. And then that's approximately 2 feet up to the top of the water level. So our staff, and we also have a staff gauge here, which we read off of it. And then we set our instrumentation to read the same as what the staff gauge does. And it's 3 feet in this case. Does that make sense? Okay. And that's another example. That's how stage is measured at the Pack Creek gauge. It's a big advantage is that we don't have something in the stream that can be ripped away by a flood. Pack Creek, the downside of this was the water went over the top of the bridge last year. So that's a picture of our gauge. This is our gauge, Mill Creek below Pack Creek. It's down at the wetlands. Above, it's near the mouth of the Colorado River. And this is kind of a typical setup. They're all powered, most of our gauges are powered with a solar panel and a 12-volt battery. They've got the gauge height data is recorded every 5 or 15 minutes. This is a little thing, we call it a bubbler. It's got a little mini air compressor in it. And then there's a line hooked up from here that runs down to the creek that keeps a constant pressure on that line. And then the high grade pressure sensor, the pressure transducer inside this box measures the back pressure on that line. And then it converts it to feet of stage. And then it's also in this box is a little satellite radio transmitter. And so data is transmitted, it's logged electronically in here, and then it's transmitted to the USGS. This is GOES, it's the geostationary weather service satellite. It's transmitted to every 15 minutes or hourly. That's how most of our stations are set up is to use this system. And just to sort of tie into what the Weather Service does in their kind of role in flood forecasting, they kind of have a direct line to all of our data. They suck it in off of their satellite. So they do that because just kind of what I was explaining about the water alert, if something happens with the internet or whatever, they don't have to rely on that to get the data. They have a direct line off the satellite to get it in an emergency type situation. So this is how do we measure flow or CFS? So the gauge itself just measures the height of the river. So we have to build something to convert that height or stage to flow. And we do it by going out and physically measuring the velocity of the stream, measuring the depth and the width of the stream. So this is down at the Mill Creek below Pat Creek gauge. It's the bridge that you can no longer walk on. We got some local looky-loos there in the background. We also get in the water and weight it. This thing here it's called a flow tracker. It's got a velocity sensor on it. So it measures how deep it is, and the little sensor on there tells them how fast it's going. He does that 25 times walking across the stream. He kind of add it all up and gives you the cubic feet per second. It's got flow. I should have put this up on the slide. Flow is velocity times area. If you remember to math, you have a cross-sectional area that's feet squared, and we're measuring the velocity in feet per second. So feet per second times feet squared is cubic feet per second, or feet to the third power per second. Feet to the 1, feet to the 2 equals feet to the 3 over seconds. And then that's our 3 thingy. That's what Bago calls it. A little pontoon that we hook onto our boat, and then we drive the boat back and forth across the river. And the boat, this thing works with, it's called an acoustic Doppler current profiler. It uses the same principle as Doppler radar, but it's Doppler sonar. It measures the velocity of little tiny particles of sediment in the water, and shows you the whole cross section of the river. So this is, we basically use the same methods to measure tiny flows of water and big flows of water. So this is like if he waded across the river, you'd measure all these depths and get all these velocities, and do the math to get your CFS. This is a printout of what we get when we use that acoustic Doppler instrument. We get the velocity all through the water column, basically, and we get a really sharp image of what the depth looks like of the river. Yes.
In your very first slide, where you showed the gauge in New Mexico and the guy was suspended over the river, how was he measuring?
He was doing it, and I don't have a good picture of it, but he is basically using the same instrumentation that, this is Noah Derrick. He's in our office. He's actually in all these pictures, but he's using the same instrumentation basically that we're using here. Down this line, we have a heavy weight that looks like a fish, and then above that weight is a current meter. It's a mechanical current meter, and it looks like a wind sensor. It spins around, and the faster the water, the faster the little cups spin. And it sends a signal up this cable and hooks onto this device, and that device counts how fast that thing's going. Every revolution, the little cups it makes an electronic connection. It actually makes a little click. It's a really old-fashioned technology, but it still works, and we still use it. Back in the day when I first started, you had to wear a headphone, and you'd have a stopwatch, and you'd count how many clicks you'd get in 40 seconds. Yes. We are the green cable, Colorado. The cableway on the Green River is gone. We don't use that anymore. The San Juan we still do, and the Cisco cableway we still use that. So we're kind of like the guy in the old picture. We don't wear a tie or hat usually when we're out there, but yeah, we use a boat. Yeah. And we're probably going to start using a boat at Cisco too, at Colorado at Cisco, because that cableway is getting to the end of its life. With the ADCP here, it makes it a lot easier to do things than it did in the past. Before, like when folks had to get on these cableways and drop this big, they'd have to use a 100-pound weight to find the bottom of the river, because you have to physically drop it down and feel the bottom to figure out how deep it is. And then you have to let your meter sit there for 40 seconds while you count how fast it's going. In the meantime, there's like big cottonwood trees and everything else coming down the river, and your thing's down there 12 feet deep, this 100-pound weight. So you just like to get the thing up before it snags you and pulls the whole thing in the water. So this thing is great because it floats on the surface. There's a lot less danger. The problem is when you get the big high silt concentrations like we get around here, it doesn't work. The beams don't penetrate through the sediment. So that's why we still keep this old-fashioned equipment on hand. Cynthia used to work for the USGS, so she knows some inside baseball stuff here. This is if we can't get out and measure it, like in a flash flood, we have some other ways to figure out how much water there was. We call it an indirect measurement. It's also referred to as a slope area measurement. And what we do is we go out and we flag and survey in all the high water marks along the banks of the river. And then we survey in cross sections, and we put that all into a fairly simple computer model, and it gives us a number of what the theoretical flow should be there. It takes a lot of work and it takes a lot of time, and it's not very accurate, but it's kind of the best we can do. When a flood happens that lasts for less than 15 minutes in a flash flood, there's just no way we can get there to physically put those instruments in the water to measure it. So we take those individual measurements when we're there at a point in time, and we plot that up with the stage. And we call it a stage discharge rating table. So this is Mill Creek below Pat Creek, near the mouth of Moab. This gauge has been there since 2018, and we've made 85 different measurements during that time. This is in a logarithmic scale, both in the horizontal and vertical. The horizontal is in discharge and the vertical is in stage. But we can kind of think of this as calibrating a gauge. We're trying to dial in what different stage means for different flow. So that was as far as we had the Mill Creek below Pat Creek gauge last summer. You can see those dots at the top. Those were those indirect measurements that I just mentioned. Those were surveyed in that way. So we had some definition up there at the top, which is right around 1,000 CFS. We measured that picture that had Noah and Chad and Emily in it. That we measured that 500 CFS or 497 CFS last July. We could see the water coming down from the upper gauges, and we knew we had time to get over to that gauge because it's right in town, and get set up to actually measure it. That one is a slope area measurement that we did in 2021, is 931 CFS. So we had pretty good confidence up to that, as of last year. So this is kind of our segue into so what happened last year? There's another picture of our gauge. This is just after the flood. You can see the gauge is still there, which is good. There's the bank at 13 feet, and the last one there, the top of that is right at about 13 feet. That was how high the water got. When if you could see, you know, if you could zoom out from this picture, this is at the wetland. So it's all flat ground, like for, you know, probably a couple mile radius. So you can just, you know, how bad it was when creeks go over bank, they go everywhere because they're not constrained anymore by the channel. So that's when things get messy. So it's also kind of like no man's land as far as our gauge. We don't really know. We don't have any data to know what the flow is doing when it gets up that high. So NWIS Web is what the USGS website is called. That accidentally threw in some jargon there. So this is the old legacy page, but this is kind of what you would have seen from the peak on August 20th last year. You can see flow went up, and then there's that gap where it's not showing anything until the stage came back down and the computer could start computing flow again. So yeah, that's our highest calibration data points. Yeah, and the rating table wasn't defined over 1100 CFS. So after the floods, we went back and we made a couple more slope area measurements. We actually did 2 of them there. The first event was on August 11th. That wound up being 2600 CFS. That one kind of gets lost in the people's memory, but there was actually flooding down 100 South past Zacks on that event. And then the big one, 5800 CFS on August 20th. So you can see how the slope of the line, it lays over it. And what's happening is that with a very small increase in stage, it can be this huge increase in discharge because you have so much area to fill up, basically.
Calculate the flow in those areas that are flat and long. You know,
It's, yeah.
That can be 0 to.
It's complicated. It's like that 5800 CFS number is at best plus or minus 25% error, probably worse than that because it's just what you said. The flow is all flowing through all the brush and trees and flat area that's down, you know, past or downstream of 500 West, while in town too. We try to pick sections where it's constrained. So when we did our measurement, we did it below the bridge at 500 West. It was mostly constrained, and it's still a very wide area, and it was a giant mess. But at least, you know, there was no way we could have done it like upstream in town where the water was flowing around buildings and everything else. It would have been just way too complicated. We did do as kind of a backup check. We went up to Power Dam and measured up there because all the water was constrained in the channel up there. And also there used to be a gauge at Power Dam. So we could kind of compare that value to what happened there in the past. And I think I have a slide that kind of shows that. Oh, and then one of the reasons we have so many measurements here and why it looks like a shotgun shot there at the bottom is there's beavers down in the wetlands, and beavers and stream gauges do not get along. The water, it looks like you have a giant flood and it's still 2 CFS, but a beaver just decided to build a dam that day. So these are kind of some of this is a big table. There's like a lot to read here, but the ones in the highlighted yellow are the values from the August 20th event. The Mill Creek, the upper Mill Creek gauge actually had a bigger flow earlier in the year, but it didn't cause a lot of problems in town. And I have another slide that shows this a little bit better, but you can kind of see the flow. This is their gauge in town, down at the bottom end of the drainage, about 5,800 CFS. This is that upper gauge at Mill Creek. In the same ballpark, it's within the range of error, 5,600 CFS, but this is also above Pack Creek you can see there's the Pat Creek gauge, which is significantly a ways upstream at the Pat Creek Road Bridge. That only had 290 CFS on that day. So most of the water on August 20th, or it came from the main fork of Mill Creek and the North Fork of Mill Creek.
If both drainages went that big, where would the high water line
Of,
Pat Creek and Mill Creek lie?
oh, if Pat Creek was,
The same,
if Pat Creek had another 1,000 CFS.
where they both got dumped on at the same time.
Yeah. Yeah. I was thinking that when I was looking at the radar coverage, like if the storm would have been a little bit bigger and covered the Pat Creek drainage as well, yeah, it would have been even worse.
What's your guess of where the high water line would be in Moab and Gages?
Yeah. The confluence is downstream. It's downstream of the, the Zach's parking lot area. I mean, I don't know. If like, let's say Pat Creek had 2,000 CFS, so another 2,000, that's 8,000 CFS. I mean, plus you would have had more. Well, Pat Creek has gotten up close to that value in last summer. So it would be, be downstream of there. I don't know. I know there was a high watermarks over by the hospital. Yeah, possibly. Yeah. I mean, that's a guess, but. Yeah, so those are our peaks on Mill Creek last year. And just for comparison, this gauge ran for a long time. It ran a couple of years in the near the turn of the century, and then it ran from 1949 to 1993. So there's a long period of record there. And the peak for the period record is actually kind of in this ballpark. So back in 1953, it was 5,100 CFS on Mill Creek. Things looked a lot different back then, obviously, but so that's kind of those are our peaks. This is the Mill Creek near Moab. This is the power dam gauge. You can see multiple peaks back in the 50s and 60s, over 5,000 CFS, even as far, as close as in the mid 70s, big peaks of over 3,000 CFS. So these are kind of what, shots of what happened. Oops. So Pat Creek, let's see here. Yeah. Okay. This is when Pat Creek went big, it went close to 1,800 CFS on August 11th. If you look over here this is the Mill Creek gauge. You can see like most of that water probably came from Pat Creek. It's the peaks are pretty similar. This gauge, well, we'll get to that in a second, and then the August 20th peak, pretty small. And then that's the big, remember, this is logarithmic scale. So this is going up from 1,000 to 6,000 up here. The comparison, this is the upstream gauge, Mill Creek at Shealy Tunnel. This gauge is actually above the tunnel diversion. But you can see the biggest peak there actually happened in early July 26th, I think it was. And what happened is the peak down here in town was much smaller. And we call that peak attenuation. You can kind of see it in this graph. You can see how sharp this peak is and how kind of wide and spread out this peak is. So if you think of a peak discharge, people want to know what peak discharge, because oftentimes it doesn't matter how long the water level is high. If it gets that high, it's going to do damage, right? But what happens is at the head of the flood, the peak is very sharp, and then as that pulse of water flows downstream, it spreads out, and so you wind up with a smaller peak. You wind up with the same volume of water, more or less, but a lower peak discharge. So yeah, and then on that event on August 11th, we had most of the water coming from Pat Creek. And then on August 20th, we had hardly any flow from Pat Creek, but we had high flow on Mill Creek and the North Fork of Mill Creek. And then Mike's question is like, yeah, what if you had all this combined on one event? It'd be pretty ugly. And this is just another kind of zoomed in view of these graphs. You can kind of see. So this is August. This is the August 11th event. You know, big flow at Pat Creek, translated into pretty big flow here down at Mill Creek. And this was the event that did go over bank on 100 South, flowed down the street past Zach's. And then not much at the upper Mill Creek gauge, you know, a couple hundred CFS. So in this August 11th event, most of the water came from Pat Creek. Sort of contrast that to the August 20th event. We have a pretty good amount of water there at the upper Mill Creek. Hardly anything from Pat Creek. It's just a blip down here. And then this huge amount of water down at the downstream end. So the drainage made up that difference in the North Fork and, you know, downstream of our gauge, basically. Yeah, just a reminder what these were. And sort of in schematic view of things. You know, we measured this. We were able to do another one of those slope area measurements. We were able to get a good value on the upper gauge. We measured there at Power Dam. We had our gauge at Pat Creek. We don't know what Pat Creek was like. You know, this gauge is quite a ways upstream. We don't know how much water was gained through Spanish Valley. The storm came over Spanish Valley and dumped a lot of water in the valley. So that's a big question mark. We also don't know how much was lost to the streets. The water went everywhere, and a lot of it didn't come back to its channel. So where we measured it, we maybe didn't capture all of it. So those are some fairly big unknowns. Plus, and also the inaccuracy of our method. You can see plus or minus 1,500 CFS. It's kind of a lot.
Were you able to go around on the streets and see where water was going? You know where the storm drains go?
You could see high water marks, but kind of like from your last question is like we were looked for a spot where it was all constrained, and the best spot for us to figure that out was kind of below 500 west. There's a wide enough floodplain there, and the houses on either side were high enough that it's constrained in an overgrown tamarisk Russian olive choke floodplain, but at least it was constrained in there. One of the fudge factors we use in our computer model is we call it a roughness coefficient. And it's just a dial. It's an estimate we make of how much friction all the river and the trees and everything else are putting on the water. So we kind of got to dial that way up when the water goes through a forested area.
This seems to be all monsoon. What do you expect from snow?
Not nearly as bad. And I'll kind of talk a little bit about that. We don't, the Weather Service, they don't predict, they don't make predictions for Mill Creek. I wish they did. They have a very robust computer simulation model that takes into factor snowpack, current flow conditions, and weather conditions to give a prediction of what peaks will be and what future flow will be. They don't unfortunately do that for Mill Creek. But I'll show you here in a little bit what our past peaks have been. And you're right, they're all monsoons. So the question was, sort of wrap this up. Was this a normal monsoon last year? That's basically us. So the answer is not really. It was fairly intense. And I mean, that moisture has continued up till now, basically. And the flood recurrence interval, we get asked this question a lot too. Since that old gauge of Power Dam was there for a long period of time, we can actually do the flood probability for that gauge. And because of those past peaks, I'm pointing at the wrong one. This is the power dam gauge. The 25-year to 50-year flood event is somewhere in that range because those peaks have been seen in the past. Assuming the people that are doing my job 50, 80 years ago, that they did a good job in measuring that. I don't know. I can't vouch. Well, I can vouch for them. I trust them.